All right, my friends, let's keep on playing with macro markets and quant. Right now, we're working on the national income project, specifically looking at the relationships between quantity of output sold and real gross domestic product. So at this stage, you have your national income project locked and loaded. If you're following along, you're not part of the class this semester, or you're working on this as a researcher, go to Market Observatory, go to the National Income Project. We go ahead and gather data from the BEA. We formulate it as an income statement for the whole US economy. Right now, we're deep diving, trying to learn our skills, quant skills, in the context of macro business econ. So we've downloaded the data, we've cleaned and curated, loaded it in. We did some EDA on general prices and quantities and the top line level. Now, what I want to do is see how quantity moves with real gross domestic product and the top-down profit framework we've talked about. We know the two theoretically should be related. The volume of goods that I sell should be related to the real gross domestic product change, right? Because real GDP is trying to focus on that volume of goods and services, just like what we're trying to do with the top line. So I want you to go ahead and load in the macro data. That's the macro data annual file. We would have to do this separately for quarterly. Load, it's in your project within your data folder within that project. Now, I want you to dip into that data set and go on and grab just GDP C1. Let's make sure you know what we're talking about here. So macro annual law. Boom. All right, so this is the data set that's already been created. It's got date, variable value, and delta. The value is whatever is the quote unquote level of that series for TB3MS. Um, I'm a big enough nerd that I know that that's the Fred moniker and ticker for the 3-year constant maturity treasury yield. If you're not as big of a nerd as me, how do you know that? Go to the metadata. Each of these files have metadata that I loaded inside of there. You can detail all of it. So what we want to do is go ahead and grab from that long file. We're gonna, oh, I just broke my own code. Oh, I'm gonna use a pipe operator to go ahead and dip into it. We're gonna create a new object called temp GDP. I want to filter only the GDPC1. That's the gross domestic product real version. And I want to grab only two columns. If you think about what we have, I need dates. And I'm gonna keep only that. What's the other one? Delta, delta, delta. See the way that it's even typed, it's lowercase d, very case sensitive there. So I need those two. Those are the only two I'm going to keep, not even the variable column, because I'm only filtering out one of them. I'll drop any of the NAs. And then again, when you have joined us with some of the other videos, code, etc., you know, the way the BEA stores their percentage is that 5 is 5%, but our calculations, 0.05 is 5%. So divide by 100. Let's make sure that works. Boom, beautiful. You are now our experts. So we're going to focus on the deltas. The reason why we're focusing on the deltas and not the levels is because of this concept called stationarity, technical term, time series econometrics. The idea is that when you have some series that tend to trend through time, it's hard to tell whether or not my model that's trying to explain or predict something is picking up really the underlying economic behavior or just the time trend. So what we want to do is be able to difference away from that. The way you difference away from that is with the delta. So that helps. I want to merge that in with my GDP data. We'll use an inner join. Remember, the join function's better than the blind binds, and the join inner is just going to take all those that they overlap and it's going to drop the ones that don't. I never done that with both fingers, but drop the ones that don't. So we'll rename them RGDP and rev.q. So it's weird, right? The way that that works inside of this Dippler structure is that I'm going to rename, I'm going to pick my new name equals my old name. My new name equals my old name. And in each one, make sure you got those pipe operators to tell them what they're doing. When you're doing the inner join, make sure you join it by the date. I'll even put it there so you can see it. Join it by the date. All right, so let's, oh, now I got a new object called real GDP.quantity. That's going to be wide. And you can look at it too. You can go over here and click. And this is the way a human would read it in Excel, right? Where it's dates in rows, fields in columns. For our purposes, it's going to be a little bit easier, faster, computer savvy to put it in long form. That's pivot longer, put on your pipe operator. And you need three things. You need, what are the columns I want to pull? Well, there was only three, and I don't want to pull the date because the date's going to just be that singleton. And then what I'm going to have is GDP and Q. I'm going to call them variable, and the values I'll call them delta. I could have called them whatever I want, but this naming structure is consistent with our other naming structures, helps us as programmers to remember. Boom. Now I got it. Boom. Real GDP quantity. Boom. Let's call that up. So take a look, 1948 in row one. That's the real GDP, and it's delta 1948 again in row two. Oh, but it's the variable rev.quantity. Stack, 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 stack. All right, so we want to plot this out. Now, the fact that they are stacked means I don't need two geom objects. Just the geom line will do the trick for us. So I'm going to have x's as dates, the y's as the deltas. Where does that delta come from? I just made an object called delta. I want to color them by and group by the variable. Where does that come from? I just made something called variable. So that's how it's going to allow us to actually overlay two lines. I said two and I held up three, to overlay two lines. We're going to put points on them just so you can see the individual pieces, and the rest of the stuff is just nice labeling, etc. Boom. Look at that. That's beautiful. I mean, uh, revenues and GDP are close cousins. They're beautiful together. Theoretically, that should be the case. The top line of my revenue should be built from the volume of stuff that I sell and some pricing. And real GDP, that real piece, should be about the volumes. And you can see their growth rates are identical, virtually identical. So that means that you can do all sorts of explanatory and predictive work. If you know real GDP, then you can start to predict and explain your top line revenues. Beautiful. All right, so let's use that to our advantage. Let's compute the correlation between those two. Use the core command, COR on the revenues and the real GDP, and it's 0.9. Huge, right? I mean, that's exactly what you would expect by looking at something like this, and that's on the deltas, and that's not even on the trending levels that we talked about in other exercises. So this is a really great fit for us. What I want to do is start to get to this notion of a predictive model. Notice I'm not saying forecasting, predictive. For that, I'll use a simple linear model. I'm not going to go through the troubles of checking to ensure that these are stationary after the first differencing like we have. Those are complications that are beyond our particular structure here, but I want to pull into the object that I made. I want to use the LM command, which is a linear model. And remember, it's always y tilde x, y tilde x. I want to explain revenue.q with GDP. I want to explain revenue.q with the GDP. And then I want to summarize that. Boom. Now, if you were trained in Excel, Python, and SAS, and Stata, whatever it is, you know, the regression frameworks always look kind of like this. And the coefficient on your X variable that you're using to explain, oh, right there. We could start talking about, is it statistically significant? 3 stars, maybe 3 stars means yes, it's statistically significant at high levels of confidence. 1.05, what does that mean? Well, a 1 percentage point increase in the growth rate is associated with a 1.05 percentage point increase in the quantity growth rate. Okay, so remember what our data looks like. Let's go back to RGDP.quantity, RGDP.quantity. Oh, and look at the numbers, right? 0.04, the very top one. 0.04, that's 4%. So 1 percentage point is 0.01. So if you go from 0.04 to 0.05, then that quantity should go up about that same amount, 0.015, 0.0105, pardon me. Now, it's difficult with the language, right? Percentage point. or maybe in finance it's basis point. So just be careful. Always look towards those units. What I want to do next is create a scatter plot. For that, we're going to again use the ggplot and the x and the y. What's the x and the y? What I'm using and what I'm explaining. X and Y respectively. What I'm using is the X, what I'm explaining is the Y. On the regression framework in the LM command, I was using GDP to explain rev.q. I added dots for each of the lines and I zoomed in for you. So let me see if I can zoom out so you can see the whole plot better. All right, now this should look a little bit better for you. And you can see it's a pretty good fit. There are periods of time that are slightly different. If you were with us for some other ones, what you notice is that the time sequence isn't always just linearly up straight to the right. I mean, 1950s all the way over here. Why is that? That was huge growth in that post-World War II recovery. And, now we're in this range around 3% or so GDP quantity. We could use this for predictive purposes. The beta is the slope of that line. You can actually think about it as confidence intervals as well. Let me zoom back in so you're comfortable with seeing the code. CONFINT, that's a confidence interval. You enter in the name of your regression and your confidence level sets up a region. 0.95 means a 95% confidence interval going from 2.5 to 97.5. So what that means is that this 0.93-ish to 1.17-ish should cover the true beta. The true beta is probably going to land somewhere in there. Now, true beta is not a random variable, but these edges are random variables. So you can think of it as like the truth is there, and our region has a 95% probability of covering that truth. Once you run a regression, make sure you always do the post-regression diagnostics. We're going to grab the residuals on all these regression objects. There's several pieces. Let's see if I can clean that up. And reg dot rev, and then you go in there and you got the model, coefficients, and residuals, etc. We're going to grab those residuals. We'll call them resid. Form a ggplot with the dates in those residuals and just make them align. And okay, so again, let me zoom out so you can see. Sometimes it's wild, sometimes it's not. We want to put this into context. How big is that GDP? It's 0.03 on average. So, it's up here. So this is relatively small magnitude in some periods, but there's nothing systematic. We can see that the post-World War II period was noisier than the rest. Lots of changes structurally that we couldn't explain. The model, the link between GDP and the volume of goods sold was actually pretty darn good around COVID. I mean, the errors were near zero. So that doesn't mean that economic activity GDP was strong or that the volume of goods was strong. It means the model was strong. It was able to explain, if GDP sucked, then the quantity of goods sold sucked, but they worked well together. Let's now take the fitted values. So what's the fitted values? The fitted values are going to be those that are like the y hats. If you take the alphas plus the betas times whatever is your x value, that's the fitted value. We're going to grab those and we're going to add another column that equals fitted plus residual. And then I want to show it to you and you have to tell me why we did that. Let's make sure both of these ran okay. Okay, so you got the GDP and the revenue Q. Those are the elements of our regression. We grabbed the residuals from that regression and the fitted values from the regression. And then what I did was I added these two together. And what you get is, wait a second, this column matches that column. That's what it should be by design, right? What's the model doing? It's saying, if you can watch my cursor, use GDP to explain revenue.q. This is what you explained, fitted, and this is what's left over from that relationship. So if you add these two together, you should pedagogically, by default, tautologically, get back to revenue.q. So that's what it does. It just meant to show you that this decomposition is structural. Doesn't mean that the model is good. It just means that we can get both pieces of our model and isolate which one is working, which one's not. Next up, I want you to do some predictions. So I want you to use the regression model to predict the 2025 revenue quantity growth using the annualized GDP growth rate in the first half of 25 as a proxy for 2025, right? Because we don't have all the data. But what we can do is go to GDPC1, which is the Fred ticker for real GDP in that first half, and then get the annualized value. That's 1.1%. Maybe I could do another video to show you how you get that. So what we're going to do is create a new data frame with that object, GDP. C just represents column. 0.011, that I actually computed from Fred. I can show you how to get there, like I was mentioning. But if I had multiple predictors, I would need to have this plus whatever is the other number. Okay, so we need to feed this into the model that we just created so it has to look like the model we just created, including real GDP as the moniker of the column. Then I want to use the predict command. Predict from my model, that's the one that I made before, whatever is my new data, which is this object right here. So it's going to take my regression model, I ran the LM before, and feed in this new data point. And then what it's going to do, let me scroll back up for you. It's going to say, all right, let me take minus 0.003235 plus 1.056536 times times 0.011. That's what it's going to do for you. Instead of doing it manually, the predict command does it for you. And I added on some bells and whistles so that it spits out what it's doing, 0.84. So take that intercept plus that 1.05 beta times 0.011, and you get 0.84%. So that's the estimated output quantity growth rate. So it's not just the total top line revenue, it's the quantity piece of that top line revenue. Our model would suggest it's growing at about 0.8% this year as a whole. And then what we can do is use that to infer the level of that quantity, right? Because the level of that quantity is an index value. So what we want to do is take the last value of that. Remember, we only have a growth rate. So what we're going to do is take whatever was the 2024 value. And the way that we'll get that is with the tail function. The tail goes to the end. Now, in default, it gives you, I think, about 5. We just want to pick the last one, so we'll put comma 1. So dip into that wide data frame, grab the output, and only the last one. Then what I want you to do is create a gross outcome. That gross is used in a couple of ways here, right? Gross output, and then a gross growth rate. 1 plus whatever is that rate of change. So let's say, pause for a second, like let's say you have something that is growing at 5%, and then you want to figure out, well, what's going to be next year. So take the current level, like 100, and you don't multiply it by 0.05. What you do is you multiply by 1.05, 1 plus 5%. So you take the current level times the gross growth rate. And that's what this is doing here. Take the last level times the gross predicted growth rate, that predicted value of 0.84%. Again, some pretty formatting, and you get 118.06. That is the quantity level we expect for all of 2025 through its ups and downs. I went ahead to the BEA and I called up through their interactive data, the chain type quantity index for gross output. We only have data through the first quarter of 2025. We made a prediction throughout all of 2025. And, right now we're trucking along at around what we would think, 118. So our forecast so far is working well. All right. That's it for this video on GDP, quantity of top line, and we'll work on some other elements coming up soon.